Last. Minus 9. We combine the two inner ones. These also, that's kind of curious. Okay, so we have x squared minus 9. Oh, all right, okay, good. This is fine.
I have a feeling you're going to make
No, this is good.
You're going to make this
great.
hard.
I told you we're gonna, we can take what we
You are gonna make it hard.
Go back to something easy. X minus 7. What do you think this is gonna be? X plus 7. First comes first.
X squared is going to be x squared.
Outer?
Plus 7x.
Plus 7x inner?
Negative 7x.
Negative 7x and last?
X squared.
49. Negative 49.
49.
Minus 49. Look at these. These two inner ones also cancel out.
Wow.
We do more.
X minus 6, x plus 6. Let's take a look at this. What do you think this is going to be?
It's going to be x.
Don't you see that the outer and inner is going to cancel out?
Yep.
Outer and inner is going to cancel out. The outer and the inner cancel out. The outer and the inner cancel out. And the outer and the inner cancel out. Now, what is common about these? Let's take a look. Minus 6 plus 6. Minus 3 plus 3. Minus 4 plus 4. Minus 7 plus 7. They're all the same. Whenever we have something like that, don't you see that the outer and the inner will cancel out? Because we have a positive number times x and the same negative number times x. So when the numbers are the same, we just have different signs, the outer and the inner will cancel out. So if we see this and recognize this, can't we just skip down to x squared minus 36? That's a pretty good shortcut. That's a pretty good shortcut. Let's do a couple more. These are good. I like these. X minus 5, x plus 5. We see that the outer and the inner is going to cancel out. We have negative 5x, positive 5x, right? So can't we just skip that step? First times first, we have x squared. And last times last is going to be negative 25. Negative 25. Nice. Nice. We have x squared minus 49.
You're on camera.
Look at these. They're all kind of consistent. Right? This breaks down into 6 times 6. But it kind of has to be because we multiply 6 times 6 to get there. This breaks down into 5 times 5. Well, it kind of has to because it came from 5 times 5. This breaks down into 4 times 4. Of course, it has to because it comes from 4 times 4. This naturally comes from 7 times 7. What are these numbers? What does it make these numbers?
Square.
They're square numbers. Square numbers break down into the same thing times itself. Square numbers break down into the same thing times itself. Square numbers. Yeah. So, can we do this in reverse?
Oh, well. Knew it.
Can we do this in reverse? If we recognize the difference of two squares, can we immediately write it as the root of this, which is x, minus the root of this, which is 5, times the root plus the root? Can we do that? It's where it comes from. Is this the difference of two squares?
Yeah.
It's the difference. Now, not the sum. Not the sum. It's got to be the difference. And we can see why. We can see why because in the case where we have a positive 5x and a negative 5x, we have a negative times a positive. So in this case, it has to be a negative answer, right? The rules of multiplying, right? The signs have to be different. So it has to be the difference of two squares. Can't we immediately write this as x minus 4 times x plus 4? What can we write this as?
7
X.
minus.
Give it to me nicely.
7 times x minus 7.
Sure. The root minus the root times the root plus the root. The root minus the root times the root plus the root. The root minus the root times the root plus the root. And when I say root, it's the square root, meaning what times what? What's the square root of 25? 5, because 5 times 5 is 25. What's the square root of 36?
6 times 6.
6. What's the square root of x squared?
X
Times x.
X, because x times x. So can't we immediately factor this as x minus 6 times x plus 6?
Yes.
Couldn't we immediately factor this by recognizing this pattern? The difference of two squares as x minus 5 times x plus 5, x minus 4 times x plus 4, x minus 7 times x plus 7. That's pretty good. So we could go from here immediately to the factored form without really doing any math. You want to try one yourself, I know you do. How about x squared minus 64? Everybody at your desk, write it down. And let's, I know we can do it. I know we can call it out. What I want you to do is write it down. And see if you could immediately factor this using this pattern. Good question. We'll address that.
Oops.
All right. How does it factor?
8.
X minus 8.
X minus 8 times x plus 8. The root minus the root, the root
Well,
plus
how do
8.
you
X minus 8.
Back here. Look for common factor, then you look for FOIL, and then you look for difference of 2 squares.
And then, of course,
So this step is called what?
factoring the difference of two squares. Now, the thing about this, as we've come to see, the actual procedure is very easy. It's a matter of recognizing it for what it is. If we recognize it for what it is, we're just in very good shape. Is this the difference of two squares?
Yeah.
Is it? Is it?
It is.
It is. It is. This is a square because n times n. And this is a square because 1 times 1. Oh, I know what we should talk about. Square numbers. 1 squared, 2 squared, 3 squared. And this is very hard to do, by the way. You say one number, but you write something else. I challenge anyone. I've been doing this for a while. Let's see if I can do it perfectly. Okay, 3 squared.
5 squared.
4 squared. 5 squared.
6
6 squared. 7 squared. 8 squared. 9 squared. 10 squared.
11.
Why did you write way up there then?
11 squared. 12 squared.
13.
13 squared. And that's where I pretty much run out.
Come on, do it.
14 squared, what is 14? I don't, it's fine, it's fine. Now, maybe you can get all the way up to 13 squared. Maybe you could just get up to 10 squared. But a lot of people, we know 12 squared. 12 times 12 is 144. 11 times 11 is 121. But these other numbers,
I don't know.
1, 4, 9, 16, 25, 36, 49, 64, 81, and 100, these should begin to pop off the board. Pop off the page. These are special numbers. These are square numbers. These you should begin to recognize. So if we have this, these are both squares. How does this factor? Just read it off to me.
N plus 1 and n minus 1.
Yep. N plus 1 times n minus 1. Sure. This would be n minus 1, n plus 1. Beautiful. If we recognize that this is the difference of two squares, we can factor them basically instantly without doing any work. These, right here, I'm telling you, these are free points. You want to take these points. These questions, difference of two squares, you will see from now on the quiz that you're going to see tomorrow, of course, on the final, of course. Any math assessment, any math class that you take from here forward, these will be thrown in there. And for students who recognize this and can apply the pattern, they're free points. Because it really doesn't take much skill other than recognizing this. Let's take a look at other ones that aren't immediately obvious. How about this? 4n squared minus 9. Now this is also the difference of two squares, right? This is a square because 2n times 2n gets us here, and this is a square because 3 times 3. So how would we factor it?
2n
Minus
minus 3 times 2n plus 3.
We have 2n minus 3, 2n plus 3. Right? The square root of this, what times what, is 2n times 2n. 3 times 3. So 2n minus 3 times 2n plus 3. Good. 16n squared minus 1. Also, the difference of two squares. Certainly, difference of two squares. How does this factor?
That'd be
Four
Come on, you can-
4n, and then 4n plus 1, 4n minus 1.
Beautiful. Nice.
Wow.
Nice. Excellent.
Holy
Yes,
smokes,
it's a
what
matter of
happened?
It does not matter. It does not matter. Now, when we multiply two numbers, 6 times 2 or 2 times 6, does it matter what order we multiply them? These are things that are multiplied. Does it matter whether we multiply this times this or this times this? No, it doesn't matter the order. So 4n minus 1, 4n plus 1, or 4n plus 1, 4n minus 1. It doesn't matter. The pattern, though, is the same. 9x squared minus 64. Everybody, factor that.
3x minus 8, 3x plus 8.
Right?
Holy crap, what's going on?
Excellent. All right.
Where's Char?
N squared
What are you doing
plus
with
4.
Char? Yeah.
Is this the difference of two squares? Say no.
No.
Why not?
I don't know.
Because it's a positive.
It's not the difference.
Oh.
It's not the difference. This is not factorable. It has to be the difference of two squares. So, when you're looking for this pattern, they both have to be squares, but it has to be subtraction. It has to be the difference of two squares. There's no way to get this to work, because the outer and the inner won't cancel out unless the signs are opposite, and if the signs are opposite, it winds up being a negative number here. If we have a positive, this is not factorable. You have
So
to handle
NF?
it. Sorry?
So NF?
Correct, yes.
So
not
would you, are you gonna put a question like that up there?
factorable.
You never know.
I may, you never know.
Oh, what?
Probably, yeah.
Oh,
Never know. Maybe. But you will see these on my quizzes, on the final perhaps. The biggest thing is to recognize the pattern. If you recognize this pattern, you're golden. Let's take a look at a few more like this.
So if it's positive, you have, it's not.
Correct. Okay. Likewise, 25 minus n squared. Is this the difference of two squares?
Mm-hmm.
Yes.
But
Sure.
it's-
How does this factor? Just read it off to me. How does this factor? Factor it for me.
5 plus n times 5 minus n.
Sure. The root minus the root plus the root. Okay? We can absolutely factor this.
Swallow stick?
Is this the difference of two squares?
Where did you write? No.
Is this the difference of two squares? It's not. So we we have to be careful here. This is not factorable, not with that pattern anyway. Is there any common factor that we can pull out of here? No. Is it the difference of two squares? No. Is it the common factor? No. No. This is not factorable. So when we're on the lookout for the difference of two squares, it has to be the difference of two squares. You have to be on the lookout for that. Good. Negative 4x squared plus 16. Is this the difference of two squares?
Yes.
No. It's not the difference.
Oh, yeah, because it does have a negative.
You can rewrite it as 16 minus 4x squared.
Very good, honey. Absolutely. Now remember, this owns its sign. This isn't a 4x squared, it's a negative 4x squared. We could certainly rearrange this as 16 negative 4x squared. Right? To go from here to here, no worries. And then, in fact, it is the difference of two squares.
Oh,
So
okay.
you may have to rearrange things just a little bit. But if you're given this, first of all, we have square numbers, right? So we should look at it further. Yes, there's oh, wait a minute, what about that negative sign? Hey, I can rearrange it. So that thought process has to be going on. The first thing, they are a square number, right? They're one of those square numbers.
I don't understand. How come it is now because it's been reversed?
Well, is this and this the same thing? Mathematically.
No.
Yeah.
Well, it is.
Well,
This is a negative
oh,
4x squared, this is a negative 4x squared. This is a positive 16, this is a positive 16.
Right.
We can certainly rearrange them. If we do rearrange it like this is now the difference of two squares. And we can factor it as such. This would then factor as 4 minus 2x times 4 plus 2x. So it does take a little bit of consideration if we have something like this. If we can rearrange it and get the difference of two squares, it's completely valid to do. Just like we have had other equations, we haven't done many of them where we've had to rearrange them, but we certainly can. This owns its sign. So if we simply put this second, we can see it as the difference of two squares. And it is factorable. If we multiply this out, we would come back to here. If we change this to here, we're in good shape. So if we multiply this out, we can get back to here. So this factored is this. Don't get hung up here. The biggest thing is recognizing the pattern. And yes, if there's a little bit of work to do, be on the lookout for it, and you'll have practice. You'll see things like this for homework. Mostly, be able to recognize this pattern and immediately be able to write it as the difference of two squares. Good. You're really good.
So if it's
Is this the difference of two squares?
Yes.
Sure is. What's the square root of this? What times what gives us this?
And 4.
And to the fourth. Absolutely. And to the fourth. Now, you want to see something kind of interesting about this particular one?
Mm-hmm.
If we factor this, what do we get?
And to the 4th.
and to the fourth plus 4.
Good. Everybody happy with that? Keep that rolling.
I got it.
Anything more we can do?
That one can
Don't we have another difference of two squares inside of this?
oh my
This
God.
can also break down.
Minus 2 and squared plus 2.
Right. You always have to look underneath because it might reveal something more you can do. And in this case, recognize that pattern. This would then factor as n squared minus 2 times n squared plus 2 times this. Now remember, this factors into this times this. So this is going to be what this factors into times this. So this is still going to be n to the fourth plus 4.
And can't you break that down too?
This one,
Yeah.
is that the difference of 2 squared?
Pardon?
Is this the difference of 2 squares also?
Yeah.
The sum.
Oh, it's a plus. Oh, okay.
Why do you have into the 4 plus 1?
That's what, this factors into this times this. Just because this factors further, it's still what this factors into times this. It's still this times this. So this is just coming along for the ride.
Tricky.
Let's go back to the book. I think there was one left. The last one, 24. Is that the difference of 2 squared? And Melanie, you're going to answer that question.
Who? Yeah, yes? No? Yes.
One of those questions is correct. One of those answers is correct.
Yes.
It is. Why?
Because there's negative.
You can rearrange them.
7 times 11 is 49, and 5 times 5 is 25.
Well, first we would rearrange that as
Yeah.
25t squared minus 49. And then it would in fact be the difference of t squared. Good. Very good. Okay, on the next page.